Hi everyone, this is Ahmed, and today I'm going to give you an overview for logs and exponent. So the thing is start from here that why we need logs to solve our mathematical equation. You might have seen something like this in indices and how to solve this. So we come up with the rule that when we can make the bases equal, we can compare the power, that is x equals to 2. I'm gonna write it for you that when bases are equal, we can compare the power. Compare the powers or index, whatever you will say it. Similarly, if you would have like 3 power x is equals to 81, you can do the same thing, reduce everything that you can reduce. I can reduce 81 to 3 power 3 times 3 is 9, 3 times 27, and 3 power 4. So when bases, my bases are equal, I can compare these powers, that is x equals to 4. Okay, but the question here is what happens if you cannot make the bases equal, right? So if you have 2x is equals to 5, right? Clearly you here, you cannot make the bases equal. So here, the logs here, right? Log takes entry, right? I am just converging my topic in order to make you understand how we would be using logs in order to solve our equations. So what logs do? Firstly, you need to understand the structure of log, right? The structure is log takes things as a base, right? Then there would be the function. Function is the value of y, right? The y, and this would be giving you the variable that you are going to find, right? So if you see, with respect to this, if we have, again I'm writing 2x is equals to 5, you see base would become the base of log, that is 2, right here. This is the y, this was the dependent function that we were getting here. So this 5 would come here and equals to the variable that was here would be here x. Okay. So what, how we can write, you can see 3 power x is equals to 7. I can write this in logarithmic form like this. This is a log base 3, right? 7 is equals to x. Yes. And in most of the calculators, you have the option to put this different bases in different functions so that you can find your required variable. There is one more important thing. I write things as a statement so that you would understand those formula that logs can make power, the coefficient, and coefficient, the power, right? So you know that if there is a variable, this thing is a coefficient, and this thing we call a power, right? So logs enable you to make any, let's suppose we have 2 log x, right? Logs enable you that if you enables you to do this thing, that if you have a coefficient, you can make it into a power of the variable of log. So you can write it as log x square, right? Similarly, if you have this, then let's suppose if you have log x power 1 over 3, log enables you, any log with any base enables you to make this power a coefficient here. So you can write it as 1 over 3 log power x, right? It works both ways, right? Log comes in different bases. Depending upon the situation, depending on the context of the question, you can see log base 2, and there would be your function log base 3, there would be your function log base 4, there would be your function depending on the context of the question till log base 10, right? And there is also one more, that is log base exponential. Exponential is an irrational number. It takes a value of 2.71 and it's non-terminating. It's an irrational number, and you should know that in given a question, you might be given with any particular base. So it depends upon if you are converting a particular equation into log form. Look at the structure. Remember the structure in your brain, that is log would take a base here, would take a function here, and would take the variable here. So in this particular context for this, I'm going to write 2 here, 7 here, x here. So this is log 2, 7 is equals to x, right? So it depends. But most famous, there are two famous log functions that we use most of the time. That is log base 10. It is represented by only log. If you are seeing only log written, it is log base 10. And if you are seeing log base e, that is represented by ln, we call it natural log, right? This base is base e. If you are seeing ln, these are two famous logs that we use most of the time to solve equations. Log base exponential is ln. We call it natural log. Log base 10 is logs, and in most of the cases that you would be dealing, both give the same answer in order to solve an equation, right? I would give you an example. Let's suppose you don't know, like you have to simplify something, and the same thing is given. You can use solve this equation by logs only. So we can, for this kind of equation, we know there is a log form, and we can simplify it through another way. Okay, so I'm gonna take log. So take log on both sides, right? So log 2 power x is equals to log 3, right? I told you here that log can make power the coefficients and the coefficient the power. Yes, log can make power the coefficient and coefficient the power, right? So you can see here that we can write this. There is a power here. You can see this power would become the coefficient, right? So I can write it as x log 2 is equals to log 3, and this log would go there in denominator. So this is x is equals to log 3 is over log 2, and this is your answer. You can further solve it in calculator to get the value of x, right? I'll give you another example for this. So you can see that, let's suppose you have 5 power x is equals to 7, and there is no way they're asking you to write it in particular log form. You're simplifying it or doing something possible. So I'm going to do it with ln also. Taking ln is natural log that we have discussed here, right? I can apply it on both sides. Take ln on bs is both sides. Ln 5 power x is equals to ln 7, right? And then I can make this power a coefficient here, right? So this is x ln 5 is equals to ln 7, and then x would be equals to ln 5 and ln 7, right? Both would give you, if even though you would, if you would have taken here this, if you would have taken here log also, it would have given you same answer. So there is, you're not supposed to be worried about whether to use log and ln. Sometimes it depends upon the context, whether the question requires ln and log, but you have to be vigilant with regarding to that. But I would recommend you to focus on the problem solving, giving you same answers, right? Okay, so some properties, you can call it properties or rules, are here for logs. So log base x base 10 of x and log base 10 of y is equals to, when you see two logs being added, right, you can multiply them, right, simple. And when you see two logs being divided, subtracting, you can divide them. And third thing is, when log base in the function is same, you can call it a 1. Yes. So the thing is, there are particular some important notes here that I want to write, that in order to apply these rules, in order to apply these rules, you have to follow certain things. Number one, there should not, there shouldn't be any coefficients, right? If you want to simplify this, there should not be any coefficient. So you know, the make power the coefficient, coefficient the power, the coefficients would be converted into powers, right, through that rule. Second thing, that all the logs should have same basis, right? So these two things you need to take care of while applying this rule. And this particular thing is very useful that you are seeing here, that if you would have like log, from here this is coming log 2 and 2 would be 1. So I can generate, if I would see, if I have to do simplification, I can generate from 1 any log that I want. Log 2 2, I can generate log 3 3, I can generate log 4 4, or anything. Let's suppose if 5 is written also, I can write 5 as 5 log 2 2 also, because 5 is multiplied by 1. And I can write 1 in any particular, this is just I'm writing 2 because I thought about 2, because given the context, if the question requires 3 3, you can write 3 3 also. I'll give you an overview for the example so that you would be able to understand it very clearly. So we are going to do an example. Example is just that you have a coefficient log, I'm taking log base 2, right? Yeah, there could be any base given. If the question would be easier if there would be an ln or log base 10. So 3 log base x plus log, I can write here 5 log 2 y minus, we can call it 8 log 2 z, right, is equals to 0. So you can see there is a clear pattern that all the bases here are same. All the bases here are same, but I cannot apply these rules here because these rules should be applied when there is no coefficient and the bases are same, right? So this is log base 2 x power 3. I'm gonna make this coefficient a power, this coefficient the power, this coefficient the power, right? So log 2 y power 5 minus log 2 z power 8, right? Now you see two logs are being added having the same base and without any coefficient. I can write them as log 2x cube y 5, right? Minus log 2 z power 8, right? Now you see these two terms, right? I can write, because these are subtracting, and I can write them in division. Log 2x cube y 5 divided by z8 is equals to 0. That's your answer, right? So this was just simplification of it, and this fine. And there is one more important thing that's called change of base, right? So change of base works like, let's say you have log base a and x, right? Here you depends upon the context, right? On context you need b as a base, right? So there could be a question where the b is dominant and you want this particular thing to be converted as b, right? So what I'm gonna do, log ax, you want to change this base, right? You want to change this base. So this is log b x. You would change the base whatever is required, but what happens to the previous base? It would become the function in denominator, right? This a is here, you see, this a is here. So again, I'm going to give you a demonstration. Let's suppose you have log base 5, right? We want to change it to 2, let's say, right? So this is log base 2. I changed it. This function remained the same, but what happens to the previous domain, previous thing, previous base? It would become the function here. You see, got it? Previous base would become a function. I'll give you one more example. Let's suppose we have log base 10 x and we want to change it into, let's say we want it to be 5, right? So what I will do, log base 5x and log base 5 10. Simple as that, right? This change of base rule is very important while doing simplifications. I'll give you an example regarding that. So we are going to see an example regarding a question where we would be using change of base. So you can see 3 log 2x, right, plus 5 log 2y. You can clearly see that there is dominance of log base 2 here, and this minus 8 log 8z, right, equals to 0. Now you can clearly see that there is an anomaly here, that there is dominance of log base 2, right, and this is log base at 8. So we have to get rid of this base 8. Yes. So what I'm gonna do, I'm gonna start solving it. I'm gonna make this coefficient a power. This is log base 2 x cube plus log base 2 x cube plus log base 2 y5, and then minus log base 8 z power 8, right? So we have to change this into log base of 2, right, using change of base rule, right? So what we are going to do, we are going to change it in the next step that we are going to do. So this is, these two are being multiplied, being added. So I'm going to multiply them. Log base 2 x cube by 5. This thing is sorted, right? And then minus log base 8 z power 8 is equal to 0. Now I will change it in this step. Log base 2 x cube by 5, right, minus what base I required. I would make it 2z 8 power this, and this is log 2. The previous base would become a function here. You got it? The previous base would become a function in denominator. This is 8 equals to 0, right? And there would be, we would simplify it, right? We are going to simplify it. Log base 2 x cube y power 5, right, minus log base 2 z power 8, and this is log base 2. 8 can be reduced to 2 power 3, right? And I can make this power a coefficient here. So I'm going to do it in the next step. This is log base 2 x cube y 5, right, minus log base 2 z power 8, and this is 3 log base 2 and 2. You know this, that log base 2 and 2 is 1. It's going to be 1. This x that I told you, log base, when the base and function is equal, the answer is 1, right? So this is log base 2 x cube y5 minus log base 2z8, right, divided by 3 equals to 0, right? This has become 1, so I'm not considering it. So you see here, there is further simplification to this problem. This is x cube y5 minus 1 over 3 log base 2 z8 is equals to 0, right? log base 2 x cube y5 minus, I can make this coefficient a power. So when it would go there, 8 times 1 by 3 would be 8 by 3, right? So log base 2 z 8 by 3 equals to 0. When two things are being subtracted here, I'm going to put them in division. This is log base 2 x cube y5 z 8 over 3 equals to 0, right? So you can see this, we have simplified this particular equation from here till here using change of base. So if you know all these things that I've told you, the logs should be very easier for you. One thing more I wanted to tell you, that logs are eliminated by their bases. What does it mean? So let's suppose you have ln x, right, is equals to 3, and they're asking us to find x, right? You can clearly see this here, that this x, right, this x has been captivated by this ln, right? So we need to eliminate this ln, right? I told you that logs are eliminated by their bases. Okay, so ln is log base e, right? So I'm gonna take base exponential on both sides, right? We are talking about taking something as base, everything would go in power for base, right? So e ln x is equals to e power 3, yes, and then this would cancel the effect of each other, x would be equals to e power 3, right? I'll give you one more example of this. Let's suppose 1 log base 2 x is equals to 3, right? You can clearly see it here, that this x is being captivated by this log base 2, yes. So what we are going to do, this is base 2, right? So what I'm going to do, I'm going to take base 2 on both sides, right? 2 log 2x is equals to 2 power 3. This is going to cancel, x is equals to 2 power 3, right? This would work for any particular base. You can see this, there is only log. We know log is this power, log means only log power base 10. Log x is equals to 4. So you can take base 10 on both sides, and then this would cancel, and then x would be equals to 10 power 4, right? Hope you have liked my lecture. If I have helped you in any way, please considering liking and subscribing my channel so that I would have a reach, and thank you so much.